All right, my learners, you are welcome to today's lesson. We'll be looking at natural science, and our topic for today will be what the particle model of matter. And but today specifically, we will be looking at that one for liquids. So we are looking at particle model of matter, and our subtopic is liquids. So basically, we are going to see how liquids behave. All right, and how we will use the model to explain the behavior of liquid. So by the end of this lesson, you should be able to at least the macroscopic properties of a liquid. You should be able to describe the microscopic properties of a liquid in terms of the particle model of matter. You should also be able to explain the macroscopic properties of a liquid in terms of its microscopic properties. And then we should be able, or you should be able to compare what liquids and solids. All right, let's start going. Now, I would like to um, let you go through, or I would like to go through with you with these terminologies. So I'm going to start with number 10 and 11. So you can see that these terms, macroscopic and microscopic, keeps on coming up there. So we need to know their meaning. When we talk of number 10, when we talk of macroscopic, it simply means what we can see with the naked eye and experience with our five senses. So our sense of smell, taste, touch, um, and seeing, and all the five senses. When you're talking about them, then they give you the macroscopic. So what we can see. Then when we look at microscopic, we are basically saying those things that we cannot see with our eyes. Now, if we look at number one, we're looking at what model. And what is a model? A model is a visual representation of something that we cannot see. So basically, a particle model is something that is represented for which we cannot see. So, but we are able to use it to explain the behavior of what matter, either solid, liquid, and gas. Now, when we look at solid is just simply a substance that is having a fixed shape and that cannot be changed. And liquid substance is a liquid, or liquid is a substance which can be poured and takes on the shape of a container. And then gas is a substance that fills any space and cannot be what's seen. But there are exceptions. All right. So let's get going. So what is the particle model of matter says in general? This particle model of matter says that atoms and molecules are referred to as what particles in the particle model of matter. So you take note. The particle model of matter is a scientific theory used to explain that all matter, into brackets solid, liquid, and gases, is made up of what? Particles. These particles are too small to see. Into brackets, in a drop of water, there would be what? Many billions of water particles. So let's take note. The spaces between the particles are empty. Note, these spaces do not contain air, they do not contain nothing. Now let's go on. Scientists have evidence that suggests that the particles are arranged differently in a solid, liquid, and a gas. Now, when we are looking at a liquid, what are the particles? How are the particles arranged? How are they manufactured or designed in a liquid? We see. Now, when we are looking at liquids, the particles are loosely arranged, but they still quite close together. The second point about the particles of liquid is that they can move quite fast and slide past each other. And the other characteristics about the liquid is that they have weaker forces between them. So now when we compare the forces of attraction between solid particles and liquid particles, will be that solid particles, the forces will be very strong, and that of liquid will be weak. We should also see that in liquid, the particles have small spaces between them. So take note of this. All right. Now let's go on. We are now going to look at the macroscopic properties and microscopic properties of a liquid. So when we talk of macroscopic properties, you remember macroscopic properties are the properties of a liquid that we can see. One, matter can exist in a liquid state. So liquid can exist in a liquid state. Liquids are running. We can see that the water is flowing, so we can see they are running. Some liquids are more running than others. So what do we mean by that? If I have a diesel and then I have water, even though all of them are liquids, the liquid flows faster and slides better than what that of the diesel. I think here we are talking about what viscosity. Diesel is more viscous than what that of what liquid. Now let's go on to point three. A liquid has a definite volume. Yes, it has a definite volume. Four, a liquid takes the shape of its container. And then five, liquids are not easily compressible. It means you cannot compress them. Okay. Now let's go and look at the word microscopic properties of a liquid. In a liquid, the particles are loosely arranged but are still in contact. Can we see that? So when what we cannot see, we are looking at the what microscopic properties. But because we cannot see, this model has done this thing for us, is able to represent it with something we can see. So in a liquid, the particles are loosely arranged but are still in contact. Seven, are constantly moving and sliding past each other in all directions. And eight, have weaker forces between them. And nine, have smaller spaces between them. So let me say seven are constantly moving and sliding past each other in all directions. Eight have weaker forces between them. So if we compare that of solid, they are constantly moving. So solids are, they don't move, they vibrate about their mean position. And now let's look at nine, have spaces between them, have small spaces between them. So if liquids have small spaces between them, then solids will have very small spaces. All right, now let's look at this diagram. It's an orange juice which can be poured. Now, basically, what is the particle model of matter talking about this? Okay, so from the above diagram, it can be observed that liquid can flow, as you can see, can be poured from one container to another. Liquids do not have what definite shape, but liquids do not have definite shape, but do have a what definite volume. They take on the shape of the container they are in. So take note. If you pour water into a pentagon shape, it will become a pentagon shape. If it is hexagon, it will take the shape of the hexagon. So basically, water does not have a particular shape, but it assumes or takes the shape of containers in which it is in or in which they are in. All right, now let's look at C. Weak forces exist between liquid particles, but the forces are still stronger enough to keep the particles in contact with each other. Okay, is somebody saying something here? Can you hear me? All right. Now, weak forces exist between liquid particles, but the forces are still stronger enough to keep the particles in contact with each other. Liquid particles do not have fixed positions but move freely around. The liquid particles slip and slide past each other. All right, so let's take note. All right, let's go on. Now, let's look at this diagram. So, we can see that this orange juice is being poured, but basically we just see the orange juice being poured. But what is actually happening to the water particles? So this, you can see that it has been magnified for us to see. So the particles in the liquid have what small spaces. So as you can see, so particles in a liquid have smaller spaces. So when we compare that to solid, the particles in solids are even, the spaces are even more smaller. Now let's see, but not as small as in solids. The particles in a liquid are loosely arranged, which means they do not have a fixed shape like solids, but they rather take the shape of the container they are in. You take note. Now, so let's look at this. Picture one, or number one, the particles fall down due to gravity when you are pouring. Now, number two, an opening is left, as you can see. The next particle can move into the opening, leaving a new opening behind it, as you can see there. So when you are pouring, this is what is happening. Number one, the particles are obeying gravity. Number two, there is an opening left, and this opening is being replaced by the next at the back of it or behind it. Now let's continue. The speed at which the particles move around inside the liquid depends on the energy of the particles. When we heat a liquid, we are giving the particles more energy and speeding them up. All right. So guys, if you are here, can you send me a message? Send me a message for me to see that you are not sleeping wherever you are listening. So send me a message, then I will ask you a question so that I'll see whether you're getting along. Yes, I'm waiting for you people, my learners. Are you here? Send me a message for me to see. All right. Natalie, yes. Asanda, yes. Okay, I can see that. Now, this is a question for you people. Water, okay, water, mention the two properties of matter that we can see. The two properties of matter. What are they? More especially liquids. The two properties of matter. We just finished them, and then other slides, send in your answer so that I can see whether you are following. Mass and volume, you are defining something. Okay, let me do it this way. Mention the properties that we can see or we cannot see. What are they? What is the name given to the properties of liquid that we can see and the properties of liquid that we cannot see? They start with M, 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 M. But the next is a bit different. The next letter after the M is different. I repeat again. What is the term given to the property of matter, in this case liquid, that we can see? And the property of matter, in this case liquid, that we cannot see. What is the term given to that? All right, I can see that you are still typing, but I hope you are hearing me loud and clear, and I'm not too fast for your liking. All right, I'm still waiting for you, my learners. Send in your answers. Send in. All right, I think I need to remind you the properties that we can see are called what? Macroscopic properties. Macroscopic. But those that we cannot see are called microscopic properties. All right. Okay, let's go on. Yes. So one of our objectives was saying that we should compare liquids and solids. So we have seen that one of solids also. In the previous slide, we just saw what liquid. Now let's look at and let's dissect what we have here. Take a look at the picture of the particles in a solid. For example, a table salt below. Now you will see that they are packed in a regular arrangement. There are very small spaces between the particles in a solid. Particles are held together by forces of attraction. In solids, these forces are strong enough to hold the particles firmly in position. Does that mean that particles in a solid do not move at all? No. The particles in a solid move a little bit. They vibrate in their fixed positions. The more energy the particles have, the faster and more strongly they vibrate. That is solid for you. What is simple meaning? This sentence simple means, or another way of representing this sentence is that solids, when you add energy, how do we add energy? When we heat them, the particles move faster. If it is liquid, they move faster. But if they are solid, they vibrate very strongly. Okay. Do you see how we have used the particle model of matter to explain the properties of solids that we can observe? For example, the particles in solids. We have already seen that in liquids and we are seeing that in solids. So for example, this is table salt crystals and they are hard and they have a fixed shape. So that we can see and feel it. That is microscopic view of what sodium chloride. Then this one is submicroscopic view of sodium chloride. Is what we cannot see. Can you see how the chloride atoms alternate with the sodium atoms? Yes, in a fixed arrangement. Let's go to the next. Now, this is what we're gonna do. So those of you who cannot move to Kahoot with us, I just want you to answer these questions, so question 1 and question 2. And then after we move to Kahoot, and then you will also be part of it. So this one for those who cannot join us in Kahoot, and we will move there. So send in your answers. Send in your answers before we switch. Before we switch. All right, learners, are you following? Send. All right, great. Let me see. Let me see. Mm. All right. Send in. I don't know. Send in your answers. Send in your answers. So question 1A is saying what is the property of a liquid? Question 2 is saying how do the particles of a liquid move? And question 2A, why are liquids running? Does a liquid have a fixed volume or a fixed shape? All right. Get back to me, 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 my learners, my learners, my learners, my send me a wait, send me a wait. Okay. Yes. No, but I will try to make it only on Fridays. But I just want you to have a feel. Okay, so let's do this. Are you done with question one? Send in before we switch. Send in before we switch. Hello. Okay. Are my learners there? Are you there? Are you there? Okay. In the next minute, I will share the corrections with you. Then, after we go to the Kahoot, so that you will answer for me, and then you will play as well. All right. Yes, we are gonna do it. Yes, we are going to do Kahoot. We are going to do. All right. So let's see. So if you are done with number one and number two, or even only number one, these are my proposed answers or my answers. Question one says, what is a property of a liquid? And B, question 1B, how do the particles of a liquid move? So listen, a liquid is running and can flow. A liquid takes on the shape of the container it is in. The particles slide over each other in all directions. All right. Now, so why are liquids running? Does a liquid have a fixed volume or a fixed shape? All right. So we can say the liquid particles are able to move more freely and slide over each other. And then B, a liquid has a fixed volume but takes on the shape of the what container it is in. All right, that's good. Now, so let's switch and go to Kahoot. So just a moment, a moment, a moment, a moment, a moment, a moment, a moment. All right, let me share this, share this, share that. All right, can you see my slide? Yes, you can see. All right. Yeah. Okay, great. Let's do it. So you just listen attentively, then you will get the pin. So let's play this game. And I click this. So listen. Okay, classic. So wait for this is our pin. The pin is 93465. 93465. Han is already here. The lady has joined. Tyrus is here. Plantra is here. Yeah, we are waiting for you. Let's wait for, yes, Natalie. Where is Junior? Where is Asanda? Where is Homolemo? Where is Hakim? Where is Kristen? Where is Simon? Where is Lisan? Where is Zamukutle? Okay, so in the next few minutes, we will start the game and they will join us later. All right. Are you guys ready for the game? Let's do it. I'm starting now. You are ready for the game. You are ready for the game. Let's do this. Let's do it. Are you ready? If you are ready, let's get kicking. So listen, the particle model of matter is used to explain the behavior of yeah, okay. All of you got it. You got it right. Let's see the one who did it first. All right, Natalie, followed by Ntlantla, Han, Lesedi. Okay, let's go. Next. Is helium in a balloon a solid, liquid, or a gas? All right, perfect. All five. Let's see the one who did it first. Okay, it's Natalie, followed by Ntlantla, Han, Lesedi, and Tyrus. Let's go to the next. Let's go to the next. A liquid can change its shape. True or false? Okay, let's see. That's true. How many people got it? Yes. Atlanta answered first, followed by Natalie and Han. Let's go to the next. When a solid changes into a liquid, what is it? Is it melting, freezing, vaporization, condensation? Okay. All right. All of you getting it? Let's see how many. Who did first? Yes. All right. This time around, all of you got it, but Han was the first person to answer. Let's go to the next. The particle model of matter says that all matter is made up of tiny particles called, let's go. Yes, all of you go to try. Let's see who is the first person. Okay, Lantla was the first person to answer, followed by Han, Natalie, Lesedi, and Tyler. Let's get it going. What is a liquid? What is a liquid? What is a liquid? Is it a material having a definite shape and volume? A material has neither a definite shape nor volume, or a material has a definite volume but not a definite shape? Which one is it? Okay, we got it right, but let's see them who got it first. Okay, Han was the first to answer, followed by Natalie and Plantla. Let's go to the next. The particle model of matter suggests that, okay, all matter is made up of particles. There is a space between particles. Particles are always moving. All of these are correct. So which of these? Yeah, yeah. Let's go on. Perfect. All of these are correct. Is the right answer. So let's see the number of people who did it. Yes, Han followed by let's say D. Okay, let's go. What do you call the process from a solid to gas without melting? Solidification, vaporization, sublimation, and evaporation. Okay, sublimation is the correct answer, but nobody got it. So the process, a solid moving to a gas without melting or without a liquid state is known as what? Sublimation. So let's go to the next. Nobody is moving here. The change of a substance from a liquid to a gas, what is that? Okay, perfect. It's evaporation. Three people have done that. Let's see. First is Han and followed by the rest. Let's go to the next. Is gasoline a solid, liquid, or a gas? So let's see. Which one is that? Okay, four people got this. Let's see. Yes, Han first, followed by Tyrus, Natalie, and Clank. Let's move to the next. Is the particle model. Is the particle model. The particles are always moving. Can be described as what? Cognitive. Very good. We're moving. So let's see. Okay, Han was the first person to answer, followed by the CD and the rest. Let's go to the next. The particle theory of matter is a useful scientific model because okay, thanks very much. Number four. Four people have answered it and two not. Let's see. Han is still leading, followed by the rest. Let's go to the other. What do liquid particles do? What do they do? Yes, okay, perfect. They move around each other. Three people got this. Let's go on. Next, particle model of matter. Sorry. So you see solid, liquid, and gas. So you see how they are. All right. Only one person got this right, which is all right. It's only hand. Let's go to the next. What are the characteristics of a liquid? Okay. Let's go flows and takes. Yeah, five people got this. Let's see. Yeah, let's go to the next. How is the distance between solid molecules? So let's solid see. Okay, very near. Let's look at the. Okay, let's say you was the first person to answer. You are looking at the scoreboard. Let's go on. What is an element that is a gas or brittle, solid or solid at room temperature? What is it? All right, the answer is non-metal. Okay, let's go on. Next, basic unit of matter. Basic unit of matter. Basic unit of matter. Basic unit of matter. Atom. That's fantastic. Let's go on. Oh, that's nice. I love what I'm seeing. Last but not the least, this is not a liquid, true or false. This is not a liquid, true or false. Okay, yeah, let's see the one with this first. Okay, still hand. Yes, we are getting into thousands. Last but not the least, let's see the change of state from a solid to a liquid. Yes, it's called condensation, freezing, evaporation, melting. Let's see. Let's see. Let's see. Alright, melting. Let's see the one who did. Let's see. If the third person is fourth, let's say the 14 out of 20. Natalie 13 out of the third person. Okay, hand again. So the second person is let's say the third. Natalie first. Okay, so let's go on. All right. So today you did well. Your percentage is what? 55% correct. That's great. All right. Now, so let's view the report. 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 Okay, okay, so you can see. All right. That it was nice. I hope you enjoy it. We have come to the end of the lesson, and then see you tomorrow. Tomorrow we will be recapping what we have done during the week, and probably there will be a Kahoot again. All right, but you can send me your experiences, whether you like the Kahoot or not, or I shouldn't be doing it always. All right, okay. It was nice having you around. See you tomorrow and bye for now. Okay, bye. I am first again.